Hi everyone. I am Sal, an industrial engineer at RetrievalBased. Industrial engineers like me design and optimize manufacturing assembly processes by combining domain expertise, organizational knowledge, and tedious manual observations such as time studies, ergonomic assessments, and yield estimates, while reasoning in frameworks such as Lean Six Sigma and the Toyota production system. As industrial engineers, we're often struggling with workload, knowledge sharing, and post-Kaizen analysis, which limit our ability to maximize productivity, yield, and quality, and ultimately limit the bottom line for the businesses we operate in. Today, we are launching our patent-pending Kaizen Copilot tool, which is built on Lean Six Sigma foundations, to marry these three sources of knowledge and give superpowers to industrial engineers. Kaizen Copilot is an artificial intelligence agent that is built on top of our generative AI models called LeanGPT, which work with text, spreadsheets, images, and videos, and are specialized for the manufacturing domain. Kaizen Copilot helps your production managers and industrial engineers in several ways. It generates analyses and simulations in seconds that would normally take days or weeks to produce manually. It facilitates cross-pollination of knowledge between ships and factories. Copilot includes templates and tools for automatically filling out appropriate worksheets, as well as suggesting example prompts to guide users in the direction of more advanced Lean Six Sigma and Toyota production systems workflows. We'll be analyzing the performance of a station where an electronic device is assembled and packaged. We need to select the name of the process, a period of time, as well as the station on which this process is being performed. Kaizen Copilot works with Pathfinder's camera and IoT sensing capability and provides an assessment of cycle time distribution and problematic steps. We will start by looking into quality and then get a sneak peek at process variation. Let's kick off our analysis by getting an initial FMEA assessment. Getting started with this type of analysis and having team members contribute can take days, but not with Kaizen Copilot. After an FMEA analysis is approved, we can even perform a reverse FMEA against actual data to update it based on floor-level observations. Also, note the list of example prompts on the right-hand side. This list provides us with contextual suggestions on how to proceed next, in line with Lean Six Sigma best practices. Copilot is also able to fetch images or video data corresponding to the process, which helps us refer back to shop floor details. We can also ask for videos where the best cycle time was observed or those with certain kinds of mistakes. Let's ask Kaizen Copilot for recommendations on where and how to include Poka yoke into the process. Again, the system is able to imagine ways of improving the process based on step descriptions, video recordings, and shop floor readings, which the quality team can discuss and refine. We notice that mistake proofing suggested for the tighten screw step that we saw earlier is to use a connected screwdriver and enforce torque values, which is quite reasonable. Hazard analysis for OSHA compliance is another important part of process design. Performing an ISO 45001 analysis on a process requires brainstorming and bringing to bear a team's prior experiences to list various hazards, which are posed by the specific process. Copilot is able to come up with a relevant list of hazards within seconds, which engineers can refine and finalize in a single meeting. Well, we already have a control plan in place. Let's do a control plan audit based on the analytics at the back end to check if the plan is being properly implemented. It appears that the existing control plan is indeed being complied with. Let's now shift gears and get a sneak peek into reducing waste by analyzing process variability. In this case, Copilot shows us the few steps that have a high standard deviation and that we need to fix. These steps include the screw tightening step that we saw earlier. We later discovered that the screwdriver was indeed mounted at an uncomfortable distance from the main work area, which was causing this variability. Next, we'll assess process capability using Lean Six Sigma tools like control charts and histograms. Control charts from collected data help identify systemic causes needing improvement or special causes requiring attention. Kaizen Copilot provides insights and recommendations to reduce variation and improve process capability. We have Excel templates for a wide variety of Lean Six Sigma tools baked into the product, which allows the user to conveniently funnel appropriate data into a spreadsheet in the right format. In this example, the process capability report indicates that the process is unfit to meet our specs, and we will need to make some changes to it. Finally, our quality manager has been complaining about a problem related to imperfect finish of the end product, where there's some clearance left between the device's lid and its body. A key strength of GPT-based systems is their ability to reason about and find correlations between a very large number of facts and data points at the same time. Let's see if it can figure this problem out. Fantastic. It turns out that the screw tightening step we visualized before, and where torque control was recommended to us as error-proofing, might have been the culprit here. Copilot detected that excess torque was indeed being applied that caused this problem. Let's now try to analyze and improve a complete line with Copilot. Because we do not share our customers' data, we will simulate on top of a published case study for a crankshaft machining line from an auto parts manufacturer. We imported the initial data from the study into our database, as opposed to directly fetching it from Pathfinder's camera and IoT platform, which Copilot will use to perform its analysis. Let's ask Copilot to provide a flow process chart for the line, incorporating time and motion studies over the chosen duration. A flow process chart for a manufacturing assembly line in Lean Six Sigma typically follows the steps of the production process from start to finish, helping to identify potential areas for improvement and waste reduction. The flow process chart provides distance traveled and time spent on each major step of this line, including the type of each step, categorized into operation steps, transport steps, delay steps, inspection steps, and storage steps. Again, a chart of this sort will typically take weeks or months to update, whereas Copilot, with the help of Pathfinder's analytics, generates it within minutes. Based on the process flow diagram at the beginning, we can always refer back to station-level steps. This data could be coming in from our Pathfinder platform or directly from the customer's MES system. Let's now generate a current state value stream map. A current state provides a bird's-eye view of how our current processes work and helps us identify the key areas where we can optimize and improve our manufacturing operations. We learned that the process ratio for the line stands at a low 11%, with the lead time almost 10 times that of process time. Let's now ask Copilot to suggest a list of Kaizens that can improve this line. We see two main kinds of improvement suggestions. One is to minimize the distance traveled by the product on the assembly line, and the other is to convert batch processing into single-piece flow. Let's ask our trusty Copilot to simulate how our manufacturing process would look like if we implemented these suggestions. Sure, we might run into some snags like limited floor space, but a little imagination and a bit of elbow grease can help us figure out what's possible right now. The future map brings up the process ratio from 11% to 50% and reduces total lead time to 325 minutes. It looks like Copilot has gone all out and assumed a single-piece flow and constant bottleneck between workstations. There's another tool in Lean Six Sigma that can help us spot areas of waste and inefficiency. It's called OEE, or Overall Equipment Effectiveness. We now take a quick peek at the OEE chart for our current process. As we dive in, we see that the process has not been doing very well in terms of productivity of equipment. A world-class OEEs would be in the 85% range, whereas we're operating in the mid-50s. A world-class quality factor would be 99.9%, whereas we're somewhere in the 95% range. Certainly something to be worried about. Let's leave a deeper dive into OEE for a future session. Okay, folks, hold on to your hats. We're now about to dive into the awesome world of retrieval-based generation. This amazing tool allows us to connect our trusty Copilot to an organization's knowledge base, making it super easy to search for exact references that can answer any question you throw at it. For many organizations, sharing knowledge and dealing with quality issues between ships and factories can be a real pain. But with retrieval-based generation, engineers can quickly retrieve relevant documents and ask insightful questions to help analyze the process and make improvements. How's that for some serious wizardry? Being able to collect failure data throughout your organization, regardless if plants are located across the country or all around the globe, allows your organization to instantly capitalize on lessons learned in one plant or department so that read-across activities can be deployed in such a way that you not only prevent local recurrence of failure, but you prevent failure from ever occurring in the first place throughout the global enterprise. As you can see in this example, we're able to instantly derive conclusions from the Kaizen events performed across several factories. Kaizens are all about keeping people involved in the continuous improvement process. That's why we are also releasing Kaizen Copilot as a tablet app so you can take it with you on your Gemba walks. This app embeds physical contextual knowledge into the tool to proactively offer help, as well as assist in gathering operator feedback on problems and solutions. Please reach out ASAP if you're interested in trying out Kaizen Copilot. We make setting it up incredibly quick and easy, where customers can start light and gradually expand integrations without requiring any downtime. Let Copilot be a resource to your team, and we are confident you will see a quick return on your investment. Thanks for watching.